Welcome to CE 402 Environmental Engineering 2 Module 4 Part 5. In this session, I am going to discuss about the activated sludge process. What is meant by an activated sludge process? It is the major aerobic suspended growth type of biological process. And this uses the active microorganisms kept in suspension in the reactor to decompose and stabilize the soluble and particulate, that is colloidal and suspended organic matter present in the wastewater. The suspended active biomass called activated sludge, and it will be represented or measured in terms of MLVSS, that is mixed liquor volatile suspended solids. The process essentially has two distinct functions. That is, first one, namely synthesis of new cells, and then the stabilization, that is oxidation of organic matter. Then to operate the process on a continuous basis, the biomass solids generated in an aeration tank is separated and thickened in a secondary clarifier by gravity settling. The larger portion of the settled solids that is collected from the secondary clarifier is recirculated into the aeration tank and into the primary sedimentation tank in order to enhance the biological action, that is microbial action, to takes place inside these primary sedimentation tanks and in the aeration tanks. And the clarified liquid known as final or treated effluent is usually disposed into the stream. However, the effluent can be reused or reclaimed. The treatment system normally consists of three components, that is a reactor and then a settling tank and a recycle system. Reactor is basically an aeration tank, and the settling tank is actually a secondary clarifier or secondary sedimentation tank, and a recycle system to recirculate the activated sludge. This is the schematic representation. Here, the raw water coming from the primary primary sedimentation tank is fed into the aeration tank, where air is mixed with this raw water, where the activated sludge process will takes place, and the activated sludge will form, and it will be sent directly into the secondary clarifier or secondary sedimentation tank in order to enhance the sedimentation process. And this activated sludge will settle down in the clarifier itself, and these activated sludge will be collected by using some arrangement provided at the bottom of the secondary clarifier, and a portion of this activated sludge is recirculated into the aeration tank, and another portion is sent to the waste disposal, that is to the sludge digestion tank. Then this is the major process involved in the activated sludge, and when the raw or settled sewage is aerated, it develops a slightly odor, disagreeable odor and a grey color. And in continuation of aeration, this foul odor and the grey color will disappear, and it will form a brownish tinge sewage. And when such aerated sewage is allowed to settle, fine brownish flocks are settled at the bottom of the secondary clarifier, and leaving a clear water at the top of the secondary clarifier. And these flocks are known as activated sludge. And activated sludge has got an unusual property to oxidize the organic matter when mixed with the raw sewage. This is the growth pattern in a activated sludge process. In x-axis, the time is given. In y-axis, the mass of microorganisms are given. And in the low growth phase, there are three phases of growth of microbes in the activated sludge process. First phase is low growth phase, that is the quantity, that is the amount of microbes will increase inside the wastewater at a very high rate. And in the second phase, that is the declining growth rate, in this the growth will be declined, and in the endogenous phase, the rate of growth will be decreased. These are the three phases in the growth of a microorganisms. Then removal mechanism. The removal of colloidal and solids in suspension is done by physicochemical adsorption on the active biomass and by enmeshment in the biological floc. Physicochemical adsorption in the active biomass. That is, the activated sludge will collect these colloidal particles and solids in suspension, and by enmeshment in the biological floc, that is enmeshment in the biological floc. Therefore, proper mixing of wastewater with the biomass in the reactor is very important and very essential. Soluble organic solids are removed by biosorption, by matter, by microorganisms, and then by their biodegradation or decomposition and stabilization. What is a stabilization? It is a pure oxidation process. Then during the biodegradation, by oxidation of organic solids, a small fraction of soluble organic matter is synthesized into new cells. And major fraction of solids are stabilized, that is oxidized. A small portion converted into new cells, and a small portion is, the major fraction will be oxidized and stabilized. Then the part of the synthesized cell will undergo self-oxidation. That is, synthesized cells means new cells will undergo self-oxidation, also known as auto-oxidation or endogenous respiration in the reactor during the endogenous growth phase of microorganisms. The oxygen is required to support both synthesis and auto-oxidation. Normally, the oxygen needed is applied through the air by aerating the wastewater, either by surface aerator or by diffuse aeration systems. The aeration system is so designed that also support proper mixing of the raw wastewater with the activated sludge recirculated into the aeration tank or the primary sedimentation tank. Then the major sub-processes involved in the activated sludge process. That is dissolution of oxygen into liquid or wastewater. That is actually the oxidation process. Then the turbulent mixing of reactor wastewater and biomass. That is the thorough mixing by aeration. And the adsorption of organic matter, that is substrate by activated sludge. Then molecular diffusion of dissolved oxygen and soluble substrate or nutrient into activated biomass. Then the basic metabolism of microorganisms, that takes food from the organic matter present in the wastewater, and the cell synthesis. Then the bioflocculation resulting from the production of cellular polymeric substances during the auto-oxidation phase. Then the auto-oxidation of cells, that is endogenous respiration. Then release of carbon dioxide from the active cell mass. Then lysis of decomposition of dead cells. These are the sub-processes involved in the activated sludge process. Then the operation of activated sludge process. Raw sludge is given a primary treatment in the sedimentation tank. If activated sludge is to be adopted, the detention period in the primary sedimentation tank may be kept lower, that is 1 to 1.5 hours. If activated sludge process is not given, then this detention period will be higher. In this process, since there is no problem of clogging of filters, raw sewage pre-treated to lesser degree can be allowed. In this system, we are not providing any filtration system, so we can give a low degree pre-treatment. Then return of proper amount of activated sludge to the aeration tank and its thorough mixing with the primary settled raw sewage is very essential for increasing the efficiency of the activated sludge process. The mixture of activated sludge and the settled raw sewage is called mixed liquor. This mixed liquor is aerated continuously to keep it aerobic. And it is continuously agitated so that sludge flocks may be kept in suspension for a period varying to 6 to 8 hours. During in the suspension phase, these will attract the colloidal particles and suspended matters present in the wastewater, and it will enhance the physicochemical adsorption and the settlement of these adsorbed particles in the secondary clarifier. Then the aerated mixed liquor is sent to final settling tank where activated sludge is separated at the bottom of the tank. When the agitation removes, that is in the aeration tank itself, the agitation happens, and in the secondary settling tank, that is secondary clarifier, the flow velocity will be very low so that the all the flocks formed in the aeration tanks will settle in the secondary clarifier, and these settled sludge will be collected from the bottom of this activated sludge process, that is the secondary clarifier, and a portion of this will be recirculated, and major portion will be collected, and when collected into the sludge digestion tanks. After the sludge digestion tank, the sludge drying beds are provided, and the final it will be disposed of, and the effluent coming after this secondary clarifier will be very clear and sparkling, and it can be disposed of directly into the surface water or streams or rivers. This is a schematic representation of activated process as a whole. The raw sewage will first be screened, and then it will be passed through this grid chamber where grids are removed, and then the primary clarifier, that is the primary sedimentation tank. After the primary sedimentation, the sediments are collected and sent to the sludge digestion tank, and the effluent from the primary sedimentation tank is fed into the aeration tank and mixed with the air, and from there proper aeration will happen, and mixed liquor will form, and this mixed liquor will be fed into the secondary clarifier where the sedimentation happens, and settled sediments, that is the activated sludge collected from the bottom of the secondary clarifier, is returned to the aeration tank to provide the activated sludge, to enhance the activated sludge process, and then a portion will be fed into the primary clarifier also. In between, you can provide a reaeration tank also in order to enhance or accelerate the process. And then the excess sludge from the secondary clarifier will be collected and sent to the sludge digestion tank, and then where it is sent to the sludge drying beds, and finally it will be disposed of. This is the actual process of activated sludge process. Then advantages of sludge activated sludge process: lesser area is required, and the effluent will be clear and non-putrescible, and the process is free from offensive odor and flying nuisance because it is a completely aeration, that is aerobic process. Then degree of purity of the effluent can be varied according to the quality and nature of the diluting water. Then cost of installation is low as compared to the trickling filters, and the POD removal will be 80 to 95 percentage, and the coliform or bacteria removal will be 90 to 95 percentage, and the degree of nitrification can be controlled, and there is comparatively very small loss of head in the treatment plant due to clogging and etc., because there is no filtration process in the activated sludge treatment system. Then the disadvantages, this process is very highly sensitive to certain types of industrial waste. because it is a pure biological process. If the chemical present in the wastewater can hinder the action of microbes present in the wastewater, and it will lower the action of activated sludge process. It is not suitable where constant and skilled attendance is not available. The operational cost is more. It has to be ascertained from time to time that settled sludge from the secondary clarifier, a part of which has to be sent back to the aeration tank in the form of return sludge, actually remains active. Then cost of operating process is relatively high, and if there is sudden increase in the volume of the sewage, if there is sudden change in the character of the sewage, there are adverse effects on the working of process, and consequently the effluent of bad quality is obtained. And the process gives more quantity of sludge. Dewatering and disposing of this large volume of sludge creates a big problem. And the difficulty in handling large amounts of sludge produced. Sludge bulking is a common trouble which does not allow light, fluffy sludge to be easily removed by settlement, because the quantity of sludge will be very high. This is the comparison of trickling filter and activated sludge process. Here the area of land required, initial cost, operating cost, technical control, nature of sewage, pumping of sewage, fly and odor nuisance, final effluent, secondary sludge. These categories are compared, and you can directly learn this from this slide. Then methods of aeration. There are three methods of aeration is used in the activated sludge process. First one is diffused air system. Second one is mechanical aeration system. Third one is combination of these two. The first one is diffused air system. In this, first one is ridge and furrow method. Second one is the spiral flow method. In the ridge and furrow method, as in the figure shows, you can see the air main is provided from where the lateral pipes are given. In the lateral pipes, the diffuser for diffusing air holes are provided, and through these diffuser pipes air is entered into the wastewater, and which is thoroughly mixed with the wastewater, and this is the ridge and furrow method of air diffusion. And the second method is spiral flow tank. In this, only the diffuser pipe is provided at one side of the tank, and the air is diffused from this pipe, and the corners of the tank will be chamfered to enhance the mixing of air into inside the aeration tank. And this is the two methods, that is diffused aeration. Then the mechanical aeration. Mechanical aeration, there are two types of aerations, paddle mechanisms and spray mechanisms. In the paddle mechanism, the paddles are provided in order to mix the wastewater. That is, paddles will be rotated so that this wastewater will be mixed with the air, atmospheric air. Here in the first figure, you can see that the total length of flow will be very large, and the paddles are provided, that the small rectangles provided in each length of this passage, in order to provide a proper mixing. And you can see for each length the paddles are provided at the middle, and these paddles are provided in such a way that the proper mixing of air with the wastewater is continuously or thoroughly happen. And you can see a mechanical system is arranged at the outside of the aeration tank, and these paddles will be operated from this system. And in the second system, you can see that these paddles are arranged at the end of this tank, and the water is flow through this aeration tank not in a lengthy way, that is compared to the first one. And so the paddles are arranged at the end of this aeration tank. Three paddles you can see. These paddles will rotate and it will mix air with the atmospheric air with the wastewater. Then next is the spray mechanism. In this figure itself, you can see that the water is collected from this central feeding system, and this will be pumped out on the surface of the aeration tanks like a fountain. And by this fountain action, the wastewater will be sprayed like droplets, and these droplets will mixed with the atmospheric air, and aeration will happen. This is the process used in the spray aerator. A combination system is the combination of these two systems, that is diffused air system and mechanical aeration system. Here you can see that the diffused air pipes are provided at one side of this tank. At the rightmost wall, you can see the diffused air main, and the air is diffused from the bottom of this diffused air pipe, and which can be mixed by using these paddles. That is the combination of the two system, that is mechanical system and the diffused air system. These are the air mixing devices used in the aeration tanks. I hope you understood this session about activated sludge process. Thank you for listening. See you in the next class.